Hi everyone, in today's video we are going to be discussing inscribed angles and how to apply trigonometry to solve for sides and angles in inscribed triangles and circles. Please keep in mind that throughout this video I will be using some circle terminology, so if you aren't familiar with these terms, check out the link in the description to familiarize yourself with them. The first thing I would like to go over is the arc symbol, because I will be referring to it throughout this video. So this symbol is what we use in geometry right here to represent an arc. So if I were to want to reference arc AB right over here, then I would use this symbol to state or reference measure of arc AB. First, what is an inscribed angle? So by definition, an inscribed angle in a circle is formed by two chords that have a common endpoint on a circle. So for an angle to be considered inscribed, the endpoint that they are referring to in the definition in this case would be point C, because these two chords right here share this endpoint on the circumference. Remember that a chord means that 2 points must be on the circumference of the circle. So AC would be considered a chord, and BC would also be considered a chord because 2 of its points are on the circumference. And this forms an inscribed angle, which is the measure of angle X. An inscribed angle will always be half the measure of its intercepted arc. When I say the word intercepted arc, I mean that where the endpoints of the chords are, such as point A and point B, the arc that they intercept is the measure that you must half by to get the measure of angle X. So now that we have gone over that definition, let's apply it to some problems. So I'm given that the measure of arc Y is 50 degrees. And because I know that the measure of angle X must be half the measure of arc Y, I will substitute the measure of my arc Y, which is 50 degrees, and I get that the measure of angle X is 25 degrees. And as you can see, I am referring to its intercepted arc, so I'm halving the measure of its intercepted arc. Now let's apply this definition in another way. How about if we have the measure of angle X rather than its intercepted arc? Okay, we are given that the measure of angle X is 60 degrees. So if we substitute that in and we multiply both sides by 2 to get rid of the fraction here, so we multiply by its reciprocal, we get that the measure of arc Y is 120 degrees. And we know that this is correct because if we refer back to our definition, it is stated that the measure of angle X is always half the measure of arc Y. And half the measure of 120 is 60 degrees. So this checks out. Okay, now that we have gone over what an inscribed angle is, how can we apply it to solve for a side length or an angle when using trigonometry, for example? So for this problem, we are asked to find the length of side Q. I'm assuming that you're already familiar with SO, CA, TOA when we are solving for a right angle triangle for either sides or angles. So we are given that the adjacent side is 12 centimeters. The opposite side we are not given, but we are asked to find the length of side Q, so we don't really need to find the opposite side just yet. I know that this is the opposite side because we are given this angle right here. So opposite the measure of angle X is this side right here. And I know that Q is the hypotenuse because it is opposite the right angle, and the only side left is the adjacent side. Okay, so because we are asked to find the measure or length of side Q, I can see that I have the adjacent side So I need to find the hypotenuse side. So I can use right here, the cosine function. However, I still need to find my angle. So the measure of angle x, I can see that this is an inscribed angle, and we are given the measure of arc y. So if we refer back to the definition of an inscribed angle, I know that the measure of angle x will always have to be half the measure of arc y. So if I substitute the measure of arc y into my equation, I get that the measure of angle x is 50 degrees. Great, so now that I have that angle, I can start solving for side length q. Because I know I will be using the trigonometric function of cosine, I can plug that into my equation. So cosine 50 degrees and the adjacent side over the hypotenuse, which I will represent by x. So 12 over x, I will multiply both sides by x to isolate my 12, and then I will divide both sides by cosine 50 to isolate my x variable. So now I have x is equal to 12 divided by cosine 50, which simplifies to x is equal to 18.67 centimeters, which is the measure of the length of side q. I hope that this video helped you, and I will now give you some problems to solve on your own. Please let me know if you would like me to create a more detailed video on SOHCAHTOA, or any more videos detailing how to solve for sides or angles in a non-right angle triangle.